And they had beer. And so, as luck would have it, I just happened to have a 12-pack in the cooler, which I sacrificed for science. I dug up a piece of ground, poured my beer in the ground, compacted it, and 3 days later, I had Earth Systems come out and do a compaction test. And the beer ground compacted to 110 pounds per cubic foot compared to 119 for the permazyme, with the native ground at only 102. And I said, this is incredible. So now I want to check the coefficient of friction tests. So we went down to Pierce College, our local MUU, and I had 4 pads, and we got some Budweiser. And I made a Budweiser pad, a yeast pad, a water pad, and a beer and yeast pad. And so we got these all set up. And we had Daphne and her colleagues compact the soil because the Egyptians would drive cattle across the roads to compact them. And sure enough, 3 days later, I came back and did the coefficient of friction tests, and the beer-treated ground had the lowest coefficient of friction. Well, now, by the way, now we're going to go build a pyramid. So the good news is I don't drink beer anymore. I conduct field research. And what I learned was that Coors is not pasteurized, so it has more active ingredients. So I got 80 cases of Coors, and we went up to build a pyramid pad. And again, I had Earth Systems come out, and the Coors pad came out at 121 pounds per cubic foot. And what's really interesting, if you look at the relative soil compaction, the grading of the Coors pad actually exceeded the earthwork guidelines that we have today for dirt roads. Isn't that a beautiful pad? So now the first question is, can a kite pull a 2-ton stone on log rollers? We attached our nylon kite to a 2-ton stone. Whoosh! The thing took off so fast we had to run to keep up with it. So now we're building the Great Pyramid of Quartz Hill. It has 2 foundation stones and 1 capstone. We took out all the middle layers. So what you're seeing is a scaffolding with pulleys and a kite. And you'll see the kite had pulled this along log rollers up a ramp with a lot of friction. The kite's doing all the work, all the lifting. Here it is midway, going up the ramp. Guys are just positioning it, perfectly placed. But we didn't like it. There's too much scaffolding, too many pulleys. We want a dead pull. So now the History Channel's on TV, and I get a call from Dave Culp of Kite Ship. He said, you're using the wrong kind of kite. I said, well, these are the only kind of kites that are out there. What kind of kite should I use? He had developed a kite sail, doesn't require a mast, that pulls ships across the ocean. A kite that pulls ships across the ocean. Do you recognize the shape of this kite from the hieroglyphs? And I said, yeah. So I commissioned one made out of silk. The Egyptians didn't use silk. They used linen. They had a way of weaving linen so fine you could put 7 layers of linen, one on top of each other, and still see the nude human form underneath. We've lost the ability to weave linen like this. So I figured, okay, it's a half step back in reverse engineering. We'll use a natural fiber. So the question is, can a kite made of natural fiber pull a 2-ton stone along log rollers? The answer is yes. So now what do we do about scaffolding? I have a problem. First step, identify a problem. Next step, pack your brain. Third step, relax. 4 o'clock in the morning, I'm like, oh my God. If we just use rope as the scaffolding, it goes taut. Once you launch the kite, it goes taut. That's your scaffolding, which is great because the Egyptians didn't have trees. Now, the other question is, how do you get 2 pyramid stones so close together you literally cannot cram a playing card in between them? That's tough. Well, in doing my obelisk homework, when Cleopatra's Needle showed up, the one that's in New York, they had to get this big obelisk through the tight city blocks around buildings, and so they put it on cannonballs and used the cannonballs as ball bearings. I'm like, great, where am I going to find cannonballs in ancient Egypt? Well, guess what? They have dolerite, which has naturally weathers into spheres, naturally occurring spheroidal weathering. And these dolerite balls are found all over the Giza Plateau, and dolerite is actually harder than granite. So of course we start on models. The Egyptians were fantastic model builders, so I took that as a way to go. So we make most of our mistake on desktop models, figure out how to do things. I went and got some spheroidal river rocks. This is what a doctorate will get you. I had to sort the rocks. The ones that we figured out were the best were the grapefruit-sized rocks. And now we're building a step pyramid. Remember how we started off with a small pyramid, then we're going to a step pyramid. I'm trying to follow how the Egyptians did it. They started off with small pyramids, and then went to step pyramids, and then went to true pyramids. And here you are with our 2-ton stones and some spheroidal river rocks, using them as ball bearings. Stop and go, stop and go, stop and go. You remember that chisel? I went and bought some at the hardware store. They weren't gold, but I bought some. I bought 6 of them. And you'll notice in the video, these things work great. You can use them for a pry bar. You can use them as a brake. You can use them as rollers. These were incredible tools. And because these were such incredible tools, did Pharaoh assume this as a symbol of power. And all it takes to get 2 2-ton pyramid stones so close together, you literally cannot cram a playing card in between them, is 3 spheroidal river rocks and 2 15-year-old teenage girls. When I first started doing this, I was vilified in print and vilified on television by Egyptologists. They called me a pyramidiot in big letters in Time magazine. So I trademarked the name and had pocket protectors made up that says pyramidiot in English and in hieroglyphs. And all the engineers were fighting over it. Well, except that my theory works. I'm able to move multi-ton stones. So I'm really, really proud of this. This was my first expedition flag. From Wings World Quest, I actually got an expedition flag. Now I'm starting to get some credibility. So if we take 2 minutes, I'd like to share with you about 2.5 minutes of our preliminary work on building pyramids.
How do you think of something that no one's ever thought of before?
Do we take these 2-ton stones and build a pyramid like this?
We're setting out to build a couple of precision pyramids.
Okay, we're ready for kite.
The first question is, can a kite made of natural material pull a 2-ton stone along log rollers?
I don't care where we are on the planet. I can gather enough natural materials to build a kite and fly it and lift something with it.
Right now, this is time to put the money where the mouth is. Let's go! Clear, everybody! Back away from the roller!
We, on the one hand, revere ancient Egyptian science and engineering for what they did. And then we turn right around and use the typical modern sort of arrogance that said, well, they couldn't have been as smart as we are, so surely they wouldn't have done it the way we do it.
If we want to show that this theory does in fact work, we can do it right now.
Rolling. Come on, baby. Come on.
It's not quite flush, so we're talking about ways that we can get the stones even closer with less energy.
Yeah, 1, 2, 3.
I think some of the symbols that we see in ancient Egyptian art had their origin as tools. And I was struck by a particular scepter, and I looked at the scepter, and it reminded me very much of a chisel, even to the point where it had a different color tip.
We spent more energy in just moving the rock over than we did actually moving it. It would have been faster for us just to manually pull the stone over.
Daniel, one of the things when we were trying to move the stones flush, we found a little bit of difficulty trying to work with the log rollers. What do we do?
Well, we just come up with an idea that we'll use a bolt, anything that is maybe a little bit taller than the roller.
I'm glad you said that, because in Egypt, in the rock quarries, they have these dolerite balls. Dolerite is a stone that's actually harder than granite, and they have these balls that look like big ball bearings.
Yeah, so it makes sense. You can throw it underneath one of these stones and, help you move it.
I had no idea what the Egyptian scientists and engineers might have done. The issue is not what couldn't they have done and how couldn't they have done it. The issue, my way of thinking, is what could they have done and how could could they have done?